All right, so what we're going to do here is we're going to give you a brief introduction to Subversion, why we need it, what it does, and how to interact with it. The examples that I'm going to be giving you here today are going to be using the command line client, which is my personal recommendation for how you interact with Subversion. I know a lot of people are using GUIs, and GUIs are great, and GUIs are wonderful tools, but I think it's very important that each one of you learns how to use the command line interface. Number one, because usually when the GUI reports an error to you, it's going to give you the error message direct from the command line client. And if you don't know how to use the command line client, then you don't know how to interpret that error message very well. The second reason is almost every single error that I've had to help somebody out with, when Subversion wasn't behaving properly, was the fault of their GUI. And so I go and I do the same operation using the command line client, and it works. And so it's useful to have the command line client as something to fall back to. Third reason is in your professional life, you're probably going to be spending a lot of time logged into remote servers over secure shell, and you don't necessarily have a GUI available there. So you may want to be able to use the command line client then. Okay? So from the beginning, what is exactly the problem that source control or that Subversion is trying to solve? Okay? Back in the bad old days, 20, 30 years ago, when we were collaborating, I wasn't working 30 years ago, but when software engineers were collaborating on the software projects, they basically used a method that's outlined on this slide, right? They'd have some sort of shared file system on which their software code was being stored. Okay? And then if two engineers, say Bob and Alice, wanted to work on that file, they'd get a copy of that file from that shared file system, and they both work on it, right? So that's sort of that first sort of quadrant there on that diagram, right? Alice and Bob get a copy of A. In the second quadrant, they both start working on it. Okay, so I don't know if it's easy to make out from the back of the room, but Bob's is now known as A prime, and Alice's copy is now known as A double prime, right? They both made changes to it, all right? Then Alice, because she's a super fast engineer, finishes her modifications first. So she copies that file back to the shared file system, and so the shared file system now has her version, which is A double prime, right? Bob, who's a slowpoke, finishes his later, and he copies his copy back to the shared file system and overwrites Alice's changes, so Alice's changes aren't there anymore, right? So, that's obviously a problem, right? It makes it very difficult for multiple people to collaborate on the same thing if you don't have some way of preventing this from happening, okay? So, what's one way we can solve this? Early source control strategies would use an approach called locking, okay? So what that is the shared file system or the source code repository provided some mechanism for you to say, hey, I'm working on this file, right? That's a lock. So when Bob wants to modify A, he locks the file and makes a copy of it and starts working on it, okay? If, while Bob is working, Alice decides she wants to work on A, she can't. She tries to go get a lock, and then the file system or the repository says, nope, can't do that. Okay, so she's blocked. She can't do anything. Bob eventually finishes, creating A prime. And he writes that to the shared file system or the repository, and that unlocks the file, at which point Alice is able to lock and read the file. Okay? Can anybody tell me what's wrong with this scenario? Yeah.
You can't have multiple engineers working simultaneously on different parts.
Exactly. It's very limiting in flexibility. You can't have multiple engineers working on the same file. Slows down development dramatically. If Bob's a jerk and goes on vacation and doesn't check his file back in, well, then you're in a pretty sorry state because he's been working on something and he's still holding the lock. So then you've got to go in and force it unlock so that Alice can start working. Okay, so this is very inflexible, and this was what many of the very early, say 20, 30 years ago, source control systems were based off of. So a better solution is, which is what is used in most modern version control systems, is called copy, modify, merge. Okay? Basically, the idea behind this is if Alice and Bob want to work on A, they make a copy of it, and they start working on A. Okay? Bob produces A prime, Alice produces A double prime. And again, because Alice is super duper fast, she finishes first. And so she writes her file back into the repository. All right? And you might notice that I've changed this into file repository instead of shared file system because this is a bit more complex. All right? Alice writes it back in the shared repository, and then, so the shared repository now has her version of the file, A double prime. Okay? Bob finishes later on, and he tries to write, only he can't The repository says a newer version of that file exists, and it blocks his write, so he's not able to check in his change. All right? So what's Bob to do? Well, what Bob has to do is he's got to get a copy of A double prime from the server, which is Alice's version of the file. He's got to download it, and he's got to take his 2 copies of the file, his A prime and his A double prime, and he has to merge them together, okay, into one. So we have A triple prime. Once he's done that, he is then allowed to push his file up to the server, and Alice can then get the updated version of that file, okay? And so this is basically the underpinnings of how every modern version control system work, whether it be Subversion or Git or Mercurial or Darks or any of the other half-dozen version control systems that crazy people use. Okay, so all of this process seems a little bit onerous. Bob's got to download 2 copies of the file, and Bob's got to put them together. Most of the time, at least in practice in most software engineering, Alice and Bob are probably working on 2 different parts of that file. And if they're working on 2 different parts of the file, we can probably detect that these are different parts of the file, and we can automatically merge. And so we can take some changes from Bob's, take some changes from Alice's, and the tool can automatically do this process of downloading the new file, comparing them, merging them automatically, and then sending the thing up. All right? The problem only comes when Alice and Bob are working on the same file, or not the same file, on the same part of the file, on the same function, for example. In which case, there's going to be a conflict that can't be automatically resolved. And so Bob is going to have to go into that file, decide which parts of the file are correct, and then submit the deconflicted version of that file. Okay? So these little boxes right here for Bob and Alice, these are what are called working copies. Okay? Working copy is a copy of all the files in the repository at a particular version. Okay, so when you say SVN checkout and you put the URL for the Subversion repository that you're trying to clone, okay, you get a copy of everything that is at that path in that repository at the most current revision. Okay, I keep on saying the word revision. Let me sort of expand on that a little bit. In Subversion, revisions are indicated by an increasing number. Okay, so each time you make a change and you commit it to the repository, there's a new version number that's at the top. And so you can actually go back in history and say, give me version 100, if you need to look back in time and see, what did a particular change do? All right? So your working copy is fixed at a particular version until you do something to change that. Okay, so version is not going to automatically move anything from the server to you or from you to the server until you tell it to. All right? So you can work on this. It's your own particular version, and then eventually, which we'll talk about in the next slide or 2, you'll need to commit that change. All right? So I'm going to try to do some sort of little interactive demos here, sort of show you how these commands work. And we'll see. Okay. This is probably way too small. Oh, come on. All right, can everybody read that top one? Okay. All right, some of the demos that I'm going to be doing a little bit later presume that we have 2 different users, and so I'll be doing the 2 users in each of these different windows. I don't know if you can tell. Can you tell? This one's supposed to be different color, but this projector is apparently not good enough to make that obvious. All right. SVN checkout, and then I'm going to paste the URL. Okay? So let's explore this URL a little bit. Okay? This part of the URL identifies a repository, right? The part that ends in spring 2014. That identifies a particular repository, and the way you know that is typically trunk or branches are names that are well known in the Subversion world as being at the root of the repository. Okay, so the whole repository is called HTTPS from there to the Spring 2014. Then everything after that is a path inside that repository. Okay, so you can certainly try to check out from right here, and you might get a whole lot of stuff that you didn't intend to get. So typically it's best to sort of drill down inside the Subversion repository to only get the directory that particularly interests you. So in this case, I'm going to check out. Oh, come on, I didn't commit. Okay, so it says checked out revision 357. Okay, so if we look in the directory now, we've got a directory called foo because that was the last component of the path. And let's go into foo. There's nothing inside foo unless you look really hard. Okay, so this directory right here, this .svn, is very important. All right, that is where Subversion stores all of the metadata that it needs to successfully perform operations on your repository. If you're checking this out on Windows, it's probably not hidden. You can probably see it. Don't delete it. Don't touch it. Don't do anything with it. Just leave it where it is. Okay? It used to be in Subversion that these were actually sprinkled throughout the entire directory hierarchy, but modern versions of Subversion, say 1.6 or 1.7 and later, have just one .svn directory and that it uses as its workspace. So don't touch this directory. Don't look in it. You don't even need to worry that it exists, but it's there. And so if you're in a directory and you're saying, and Subversion's saying, this isn't a repository, well, then maybe something's happened to the .svn directory, okay? So that is checkout. Does anybody have any questions so far? Yeah?
On the URL that's given on the 251 website,
Yes.
instead of trunk/foo, it says branch.
Right, exactly. Perhaps it might be useful to sort of talk about something I wasn't planning on talking about today, just sort of explain the thinking behind those branch names. In most software development projects that use Subversion, at the root of the repository, there are typically 3 different directories. Okay, so we have the repo, and underneath the repo, we have a directory called trunk. We have a directory called branches. And we have a directory called tags. Okay? So under trunk is where most of your code for the project goes, right? Your main line of development is called the trunk. All right? And so, think of it like a tree. Like the main line of development is the trunk, so all your source code goes there, and this is always the most up-to-date version of your software. All right? Now, typically, you want to do what's called branching, which is where you take a copy of everything underneath trunk, and you copy it to a directory under branches. And so you can work on that copy of trunk independently of what's happening on trunk, independently of all that stuff, make some changes, and then eventually merge those changes back into trunk. Okay, this is a fairly advanced topic that I'm probably not going to spend a whole lot of time talking about today, but there's a link in the slides that you can use where you can go to the SVN book that was published by O'Reilly. It's free online. The last one, tags, is typically used to record the state of the repository at a particular time. So let's say, for example, that you made a release. You'd make a copy of the contents of trunk and stick it in tags so that you could always go back and say, what was release 1.0? And so you can look at that in tags, right? In our case, we're not using trunk. All of you just have a different branch, but it's best not to get caught up in that right now. All Subversion knows about is files and directories. It doesn't have any built-in concept of a branch. And so under branches, you've got a directory. That's where your work goes. Yeah?
So checkout is both simultaneously updating what we've done in our private workspace to you as well as what
No.
you guys have done? Or which
No.
which direction?
So checkout is what you do if you've got nothing on your disk and you want a copy of the repository. Okay, so you're saying, I'm going to check out what's there right now. And so it'll copy down the current state of that directory.
And so you would only do that once?
Yeah, you typically only do that once. Right? Yeah.
Where do you have to be in your directory to use the SVN checkout command? Do you need to be in a certain
You can,
folder or anything?
you can be anywhere that you have write permissions.
Okay, so when you call that, will it like check out the files to the directory? Or
Right, so, let me show this once more, okay? So, right, so I'm going to say check out a path, right? And I'm just on some random directory on my laptop. I'm going to say check out a path. What checkout is going to do is going to take the last component of the path name and check out the contents of this from the server into a directory called this, right? So if I say check out trunk foo, and I do ls, then it's going to check out into a directory called foo, right? So that's a directory, right? If I instead do a checkout and I take off the foo and I just do trunk, then it's going to check out a directory called trunk. Inside trunk is foo. Okay, have I just confused everyone? Yeah.
So it's maybe a silly question, but
Yeah.
what's the difference between check-in and commit?
Nothing.
Okay, perfect.
Okay. Check-in and commit are two words for the same thing. It's mostly a legacy, so there's a version control system in the bad old days called CVS, which if you're very lucky, you will never ever have to use, and it used the word check-in. Subversion is, CVS was based on files. So like the actual physical repository would be a file system that has some files, and CVS attached metadata to that file and it manipulated it. Whereas Subversion is based on based on databases. So the server component of Subversion is a big gigantic database. And so the word commit comes from the database community. Okay? But I think on Subversion client, it may let you use both interchangeably. I don't know. But when I say check in or commit, I mean the same thing.
So whenever you check out from that directory, where do you download the contents to or copy the contents to instead?
You don't have to do anything,
Okay.
right? So whenever you do the checkout, it will automatically download the contents from the remote server and put them inside this directory, right? So if you saw, like I did a checkout of trunk, right? And so it created in the directory I'm in a directory called trunk, and I can look inside trunk, and inside trunk is foo, right? So it automatically handles all of that. Once you do the checkout, it brings everything down and sticks it inside that directory. Okay, any other questions? Yeah. Sorry? You never checked your files out, but you were able to edit them. Did you maybe go to the web interface and download them? I mean, because certainly you can go to the web interface, right? So we can take this URL, look in Safari. And in theory, it'll eventually, okay, so there is this web interface that you can use to browse the repository, right? And I could say, go into some random person's, folder and download their README, right? So you can certainly download it that way and edit it, but going through the web interface is just a way to see what's going on the server, right? No. Okay, so what I would do, okay, is, for example, geez, come on, oh, come on. So what I do is, let's say you are Blair and Jay. Blair and Jay here? Woohoo! Okay, let's say, for example, that you are Blair and Jay. I would check this out right here. Okay? So what I would do is I would navigate to your little corner of the Subversion branches directory, take this URL and copy it, and then go over to here and say SVN CO like that. Okay? That's what you should do. All right, so yeah. Yes, it will ask you for your VNet ID and your password. Okay? Actually, let me show you one thing. So that is to check out your working directory, okay, which is where your assignments are going to be stored, okay, and I'll get to this in just a minute, okay. So let's say I did SVN CO, right, okay. So when you're using the command line client, and you're using it for the first time in the VM, and you do the SVN CO, it's going to put up something like this. And I know you in the back probably can't read it, but it says, this certificate is not issued by known authority. The certificate has expired. Oh my God, the world's going to blow up. It's not. Seriously, just hit P for permanently. And then it will then ask you for authentication. And so I know the people in the back can't read this. This says password for root. Okay, right now I'm root, and so it's taking the user ID for you, it'll be student. Okay, that's obviously wrong, right? Your ID is not student. So what you do is you just hit enter, all right? And then it'll say, okay, you're not root, tell me who you really are, okay? So you go to your username and you'll type in, you know, OTTEWR, and they'll ask for your password. My e-password is like 25 characters long. I can never remember it. Oops. And then it'll say your password authentication for Realm, Visual SVN Server, stored password unencrypted. I suggest you say no, but you can say yes if you want to. If you say no, let's see what it does. Okay, you might want to say yes. Go ahead and say yes, stored unencrypted, because otherwise, every time you try to do this, it's going to ask you for your password unless that's the behavior that you want. If you say yes, stored unencrypted, then it won't ask you for your password the next time. Okay? All right. So how are we doing here, folks? Are we? Yeah. That'll come next. Okay? Yeah. So a CO is a shorthand for checkout. Okay? So instead of having to type SVN checkout, you can just say SVN CO. And there are a lot of little shortcuts like that. All right? So let's move on. Pushing and pulling changes. Changes may be pulled from the repository using the SVN update command. Okay? So where this might be useful is we have provided comments to you and you want to see them. So you'll go into your working copy and you'll say SVN update. Okay, you can also say SVN up if you're lazy like me. Right, so for example, let me hop back here. Trunk. So let's say, for example, that I make some changes.
Yeah, it's kind of cut off on the very last line.
All right. We can fix that. Int main, void, bad coding style. And I'll come back and talk about add and commit in just a second. Okay, so I come and I go into trunk and I say SVN up or SVN update, whichever one you want to use. I like using SVN up. So what you see here is that it has said, I'm updating this working copy, and I've added a file called foo/foo.c. Okay? Yeah?
Is there a command just to see if there's anything that has been changed?
Yes.
Okay, because I know you can do that locally with like SVN Status.
Oh, okay. You mean a command to see if there's anything that has been changed on the server.
On the server, yeah.
Okay. The way that you can do that is there is... No, it is... I forget what the command is, but there's one. The way that you would do that is you just go and see is there a newer revision number on the file that I'm looking at. Okay, you know, in practice you're not going to be doing that a lot. You'll just say SVN up, and if there are problems, there are problems because you're gonna have to take care of them anyway. Okay. All right. So update. What's next? Does anybody have questions about update? Okay. Should be fairly straightforward. Now you push changes to the repository using the commit command, which you've already seen me use once, all right, and we'll use it again. So, I want to go and I want to fix this bonehead mistake here. Okay? And so then I want to make sure that the bonehead who made that mistake in the first place gets a copy of it. So I have to use SVN commit, all right? And so if you just say SVN commit by itself, it's going to give you probably some errors. It's going to say, could not use an external editor. Oh my God, to fetch a log message. You need to have a log message. Oh my God. And so the way that you can provide a log message to Subversion without using an external editor is you can use a -m flag. Okay? And so you'll say -m fixed some bonehead's mistake. Okay? And you press enter, and it'll send that up to the server so that when the next guy comes around and he says SVN up, okay, he'll say, oh my gosh, foo.c was updated. Yeah.
First, I guess you don't have to add the file after it's merely been edited. You only have to add it after you're adding an entirely new file.
Exactly.
The log all changes.
Yes.
And then the commit also pushes the commit to that, so it's not like I don't know.
It's not like Git, no. Okay. Subversion is server-based. There's a server. Whenever you do a commit, the commits are immediately registered on the server. You don't have to do any pushing, pulling, or anything like that. Okay. So does anybody have any questions about commit? Yeah.
So the person who made the bonehead mistake, he makes the mistake, does he commit or update it at that point?
Yeah.
For us to see it?
Right. So this guy right here is the bonehead. That's the smart guy.
Okay.
Bonehead made the mistake. He committed it. Smart guy came back and cleaned up. Okay.
So then he comes back and
And
does
so
the update.
Bonehead has to do update, and then you'll see, these two guys right here are in two different directories, right? So this is CS Spring trunk foo, and this is MTP trunk foo. I meant to say temp, but it didn't work out. Okay. Did I see one back there? Yeah. So that's actually a good question. Okay, commit by default will commit anything that is under the current directory. Okay, so let's say that I did, Emacs foo.c, and I said, oh, include guards. Why you'd be including a C file, I don't know. All right, so if I came down to trunk and I said SVN commit, right? Commit will by default go down and find any files that have changed or been added under the current directory, right? So I issued commit in trunk, and it found foo.c in foo, and it committed that. Yeah.
Just a point of clarification though, if you were to change a file in the directory without doing an add after that, it wouldn't commit it, correct?
No, that is not correct.
Oh.
That is not correct, okay? Anytime, and we'll talk about this in a couple slides, but anytime once a Subversion knows about the file and you make a change and you say commit, that change goes up. It's not like Git, where you have to edit and then you have to add the file and then you have to commit. Okay, Subversion is, as soon as it knows about a file, it will commit any change to that file that it detects when you say commit. Okay, but there is a option to commit, okay, where you can control how deep it goes. And so if you look at the help, you can see that there's a command line option called --depth. And so if you say --depth files, then it'll just commit files in the current directory and it won't go all the way down. If you say --depth immediates, it will commit files in the current directory, any child directories, but it won't go to their children. Okay? Yeah. You do sometimes have to do add, and that is the very next slide. Okay, yeah. Ah, good question. The message gets attached to the revision. Okay? So there's a command called SVN log foo.c, okay? And so you'll see that I can say SVN log foo.c, and you'll see this commit message here, right? So in real production environments, it's very important to have good commit messages so that when somebody's looking at the log, they're trying to figure out who screwed something up. They can look at it and say, oh, you know, this was probably the change that did it, and here's why they did it, yeah.
Why was the file was added, it was already written 360. Why was it at 360 not like 0?
Because the whole repository has a revision.
That's the global file.
Yeah, so the repository is tracking changes in all the files underneath the root, right? So anytime you make a change to any file underneath, it creates a brand new revision that contains those changes.
Okay, so if I edited a file, say like added like a new function to .cpp or something,
Yeah.
and then save that change, not using add or commit, just save that change.
Yeah.
Be a new revision to the
Yes.
repository? Okay, and so if you did like multiple of those, it might jump from one commit 360 to the next like 420.
So could you rephrase that question once more? So if you like make a bunch of directories and you commit those, then those are new revisions, right? Anytime you say commit and there are changes to send of any kind, that's a new revision.
So commit is what changes the revision.
Yeah, commit is what changes that. Okay? Come on. All right. So, Subversion, and this is very important, only tracks files, directories that you tell it to, right? So if you don't tell it to track a file or a directory, it won't do that. And so the way that you track files and directories is you use SVN add to tell it to track a file, or you use SVN makedir, mkdir, to make a directory that Subversion will track. Okay, so let's hop back to this guy right here real quick. Let's say, for example, that I've got bar.c that I want to track. I'll say SVN add bar.c, and I'll say SVN commit m. Okay? So now we've added bar.c to the repo. So now anytime that I make changes to bar.c, all right, it will send those changes back up to the server. Okay, so if you want Subversion to track a file, you have to use SVN add. Okay, so a natural question might be, what's the state of my working copy? And wouldn't you know it, Subversion has a tool for that. That is the SVN Status. Okay, so if you want to find out what files in your working copy have been modified or changed, you'll use the SVN Status command. And that will output a list of all the files that have either been 1, added, 2, modified, 3 are conflicted, or 4 are untracked. And it'll decorate those guys with one of these characters, right? And I'll show you SVN Status in just a second, but it's got a question mark. That means Subversion is telling you that's an untracked file. It doesn't know anything about it. If it's got an A, that means it's been added but not committed. If it's got an M, that means it's been modified but not committed. And if it's got a C, that means it's conflicted. Okay? And we'll talk briefly about conflicted in just a minute. All right? So going back to our little workspace here, if I say SVN status, right, it reports nothing. Then, if I say modify bar, and I say SVN status, it's now modified. So it'll say m bar.c. If I add a new file to the directory, and I say SVN status, right, it'll now say baz.c. Well, I don't know anything about that. Okay? So if there's a file that you expect to be committed to Subversion, it's got a question mark next to it, what do you need to do? Add it. So we'll say SVN add baz.c. We'll look at status again, and it says modified bar.c, added baz.c. Okay? So then I do the commit, and those are now sent up to the server. Okay? And I'm trying to get through this. Hopefully we will be able to. Okay? So, conflicts. Whenever you're working on code with more than one person, you will eventually get into a state where there is a conflict. If there is a conflict, and that means that you and somebody else have changed the same part of a file, when you update then you'll go into a conflicted state. Okay? The file itself will be marked as conflicted. So if you say SVN status, it'll have a big gigantic C next to it. And then the file will be modified, and it'll merge what it can. And then what it can't merge, it'll stick inside the file, inside delimiters like this. So one version of the file is going to be in the top half, one version of the file is going to be in the bottom half, and it's your responsibility to merge these two by hand, either picking the right one or picking the right things from each one. And I'll give a brief example of this in a second. Okay? But if any of your files are conflicted, you're not allowed to commit until that file is deconflicted. And the way that you deconflict a file, at least in terms of Subversion, is you say SVN resolved foo.c. Okay, so let's give you an example of a conflict. All right, so in the bottom guy, I'm going to edit foo.c, and I'm going to say printf hello world %s. Okay, and then in this guy, I'm also going to edit foo.c, and I'm going to say sed cout hello world. All right, so the bottom guy I'm going to commit first. Oops. Okay, the G status symbol means that it was that there were differences, but it was able to merge them automatically. Okay. So we'll commit that guy, and then we'll come up here and we'll say SVN up. Okay. So now it's saying, oh my gosh, a conflict has been discovered. What do you want to do about it? Okay. You've got several options. Probably the best thing to do, in most cases, is to choose postpone. So that's telling Subversion that, you know, I'll deal with this later, go ahead and continue. You can say mine conflict, theirs conflict, to you know, choose one over the other. That's generally a very bad idea unless you know exactly what you're doing. You can also edit the file. You can tell, you know, you can say diff full to have it tell you what the differences are. Okay, but for now I'm just going to postpone. And so you see that foo.c was checked out with the C next to it, meaning that it's conflicted. Bar and bars were added, they're fine. So now if I say SVN status, right, we see that foo.c is conflicted. Oh, and there are a couple other files that Subversion doesn't know about. Okay, and so these are sort of the files from the server. So .mine was the state of the file before you ever started doing the update. And then foo.c, .r362, and .366 are probably interesting versions of the file from previous, you know, revisions of the repository. Okay, so R366, if we were to say, so 366, R366, yeah.
So what's in foo.c right now?
So what's in foo.c? That's a good question. Okay, what's in foo.c is that it has merged it as best it could. And then what it couldn't merge, because I edited the exact same line, is put inside these conflict markers. Okay? So if you look, it tells you exactly which part's which. So this part right here is mine. That means that was in the file before you did the commit. And .r366 is the version of the file that existed on the server. Okay? And so what you've got to do is you've got to make a decision about which one of these do I keep. Maybe I keep them both, right? So I can delete this, delete this, delete this if I want to keep them both. If I only want to keep standard C out, then I delete that, and eventually I'm satisfied with how I've resolved the merge. I save it. Okay, we do SVN status. Oops, it's still conflicted. What do we have to do? We say SVN resolved foo.c. Okay, so it says resolved conflicted state of foo.c, and I'm now able to commit. Okay, so let me make some other changes. Okay, good. Okay, so I'm going to postpone resolving these. We can say foo.c, and then, we've got a conflict to resolve. I've resolved it in some way. And then I try to commit. You'll see that it's saying commit failed, aborting commit remains in conflict. All right, so that's what it'll get if you don't resolve the conflict. Okay? Yeah.
Two questions. What is the edit command that was given?
So what that'll do is on at least most Linux platforms, you can have a environment variable defined to a command that you want to use as an editor, right? So if you say export editor equals gedit, or export editor equals code blocks, or export editor equals Emacs or Vi, then when you say edit, what Subversion will do is it will launch your favorite editor with that file. Okay, you can fix the conflict if you want to, and then you save it and you exit out, and then Subversion will then presume that you have fixed the conflict. Right, so that's what the edit means.
Okay, and one more question.
Yeah.
The mine conflict and code conflict, I know you said not to worry about those, but just out of curiosity, which one does what? So if you say mine conflict, does it say that yours is the conflict?
I'm going to be perfectly honest with you. I have never ever used those in 10 years, so I've got no idea which one's which. So I mean, like, honestly, I've never once used those. It is generally a bad idea, unless you know exactly what you're doing. Yeah.
What would happen if you didn't actually resolve anything, but then you said you resolved it?
Subversion will believe you, and you'll check in junk. Yeah. Okay.
File will just remain with those like awkward arrows and stuff? Okay.
Yep. Yes. Okay, so just one more slide, and then we're going to do the quiz. Come on. All right, so where do you get help? Okay, Subversion can be complicated. Subversion has a lot of options, but it's very well documented, fortunately, and it's well understood. On the command line, you can say SVN help, and it'll print out all of the commands that you could possibly use. Then you can say SVN help on a particular command, and it'll print out usage information for that command. Okay? There's also a great resource that's in this slide deck, svnbook.redbean.com. This is the O'Reilly book that was once published for Subversion. They went ahead and made it open source, and it's available for free online. Okay, so if you have any questions, either come to office hours, look at the book, look at SVN help, and your life should be very easy, hopefully.